This is the solution to problem number 97 from homework 3.2. Here we're asked to sketch a graph of the function f of x equals x to the fourth. This is a power function. We looked at these in class. We know that the end behavior is going to be like y equals x squared because it's an even degree. And since it's a power function, it's going to look like y equals x squared, except it's going to be a little flatter near the origin than y equals x squared. So this is a sketch of f of x equals x to the fourth. And the rest of these problems are a review really from the previous unit on functions, where we're trying to determine if the graphs are odd, even, or neither. That has to do with symmetry. So if a graph is odd, it has origin symmetry. If it's even, it has y-axis symmetry. And if it's neither, it has neither origin nor y-axis symmetry. So the first question says g of x equals f of x plus 2. Since a plus 2 is on the outside, this is going to shift the f of x graph up 2. If we take our f of x function, which was x to the fourth, and we shift it up 2, it's going to look something like this. And that function is still going to be even. Shifting it up 2 does not affect the symmetry. So this graph is going to be even. Letter B, we're going to take f of x plus 2. This is a shift of the graph left 2. If I shift my original graph left 2, so this is my original graph, and then if I shift it left 2, it's going to move over this way, right? And that graph is going to be neither. It's no longer going to be even, and it's not going to be odd. F of negative x, so since the negative is inside the parentheses, this is actually changing the sign of x. So this is a reflection over the y-axis. If we reflect f of x equals x to the fourth over the y-axis, we get the same graph. So this is still going to be even. The next question, we have f of g of x equals the opposite of f of x. That's a reflection over the x-axis. So if we think about what's going to happen if we reflect that function over the x-axis, so if this was x to the fourth, and then we reflect it over the x-axis, this is going to be g of x, it's still going to be even. It's still going to have y-axis symmetry. The next one, we have f of 1/2 to the x, 1/2 times x, sorry. This is a horizontal stretch by a factor of 2. So the graph is going to get wider than it was before, but it's still going to be even, right? Making it wider isn't going to change the fact that it's even. The next transformation, we have g of x equals 1/2 times f of x. So this is a vertical shrink by a factor of 1/2. So the graph is going to get a little squatter, right? So if this was our original function, x to the fourth, so if this was our f of x, our g of x is going to be shrunk vertically, so it's going to be lower at every point, but it's still going to be even. So this is going to be, oh, sorry, wrote that in the wrong place. It's going to be even. For the next one, we have to perform the function operation. So here we have f of x to the 3/4. So that means we're going to do composition. We're going to put x to the 3/4 into the f of x function. So that's x to the 3/4 to the fourth, because f of x was x to the fourth. And if we have 3/4 to the fourth, this becomes x cubed. And we know what the cubic function, the x cubed looks like, right? That's our disco function. And the disco function is odd. And the last one, letter H, we have to compose f with f of x. So this is f of x to the fourth. So now we're going to substitute x to the fourth into our function. So we have x to the fourth, which is x to the 16th. And x to the 16th is an even power function, which is still a power function, I'm sorry, with a, I guess it's even, with an even exponent, so it's still going to be even.